Hi, this video is about solving problems involving Newton's second law and multiple forces acting. So in our example here, Jeremy exerts 150 newtons of force on a 120 kilogram couch to push it across a carpeted room. A kinetic frictional force of 135 newtons acts against the couch. Determine the net force on the couch and its acceleration. So when we have problems that involve lots of forces acting and we're looking for acceleration or the net force or even an individual force, it's best to set up problems like this with pictures and diagrams. And not even that it's best to do that, it's almost necessary because you have to define which direction is positive, which one is negative, and you also need to figure out which direction is the net force in and which kinds of forces are acting in that direction. So it's essential for you to set up problems the way that I have it outlined here. And so you'll see on the left, I have this section called Analyze Forces. And to do that, we need to illustrate the situation. We need to draw a free body diagram. And then we need to separately identify what is the horizontal net force and what is the vertical net force. In our class, we're always going to have one of those values balance out completely, maybe both of them. We're not going to have a net force in both horizontal and vertical directions, though. That would be beyond the scope of this series. So instead, you're going to just figure out what's the horizontal net force and the vertical net force. Doing all of this is essential before you begin solving the problem using the guess method, which is on the right. And you'll see what I mean. You'll need to be able to analyze the forces. So let's do this practice example. We're going to start by illustrating. I've already drawn it, though. You can see my beautiful drawing here. So you're pushing a couch to the right. What kind of forces are acting? So, of course, gravity is always going to be acting. So we draw gravity, and then the force that balances gravity is the normal force. My little writing pad is a little off, sorry. Then you have an applied force to the right. Okay, and then you have a frictional force to the left, but we have to be careful. We have to make sure the size of the arrows actually reflects the size of the forces. I drew the normal and the gravity forces as the same size because they're balanced. So is my applied force going to be greater than, equal to, or less than the kinetic friction force? So if I look back up here, it says he's exerting 150 newtons of force, and it says the frictional force is 135 newtons. So it's less. The friction is less. So I'm going to draw an arrow that is noticeably lower or less than the applied force. So I'm going to label that F with a lowercase f for friction. All right, so those are my four forces that are acting on the couch. The net force in the horizontal direction is going to be F net equals the friction plus the applied force. And we say plus, you're adding them together, but you also need to make sure you're including the direction because the applied force is in the positive direction and the frictional force is in the negative direction. For the vertical net force, the net force is 0 because the gravity and the normal are balanced in this case. So we're only going to have a horizontal net force here. And we can quickly determine what that net force is because we can just simply add up what is the friction plus the applied. So in this case, the friction is 150 in the positive direction. So that's going to be, I'm going to just write it right here, 150 newtons plus the frictional force, which is 135 newtons, but it's in the negative direction. So 135 plus 150, but this 135 is negative. So that means the net force is going to be 15 newtons. And that's to the right. So we've already answered the first question there. So you'll oftentimes figure out before you even get to this step over here what the net force is, and you do that by just simply looking at what you're given. You may not always be able to do that. So we can write over here the given information. We know the net force is 15 newtons. We also know the mass of the couch because it says kilograms right here, and so kilograms is the mass. So it's 120 kilograms. All right, we know the individual forces, so I can write those out as well. But actually, I know I'm not going to need to, and here's why. We're looking for the acceleration of the couch. And I know Newton's second law says the acceleration of any object is equal to the net force on that object divided by the mass. And I already have the net force and the mass right here, so I don't need to add anything. I don't need to take the time to write out my individual forces in this problem because I already know I've got what I need. I've got the net force and I've got the mass. So all that's left to do is substitute and solve. So the net force is, as we said before, 15 newtons. Let me switch to red. And the mass is 120 kilograms. All right, and so our acceleration is going to be 15 divided by 120. Put that into our calculator. We get 0.125. We're going to round that to 0.13. So 0.13 meters per second per second. Remember that a Newton is a kilogram times meter per second per second. So when you're taking newtons and you divide it by kilograms, the kilograms cancel out and all you're left with is meters per second, which is what I have down here. So that's our first example. So hopefully that helps kind of clarify some things. It'll help by doing some more examples in the upcoming videos. So that's all I've got for you in this video. Remember, confusion is the sweat of learning.